Okay, so we are ready to look at what this means. So this is a series of equations. So let's remind ourselves what RAB is. RAB is derivatives of the connections CAC in the coordinates XB, gamma C AB in XC plus gamma D AC gamma C DB minus gamma D AB gamma C DC. So let's start looking at the various terms. The ones that are going to be useful to us are R00, R11, and I think R22. So R00, it's a little tedious. We just have to sum over these indices. So A and B are both 0. A and B here is 0, and so we're summing over C. 0, 0 here, we're summing over C this way. 0, 0, so we're summing over C here, but then we're also summing over D. 0, 0, so we're summing over C here, and then over D there. Actually, let me give you these values. So I worked them out, and I'll show them to you this way. I worked them out. So here I replaced A and B with 0, 0. And I left C free. And of course, leaving C free means D is also, I haven't worked out the D either. So initially I go through these sums. So here I have 4 terms, 0, 0, 1, 1, 2, 2, and 3, 3. Here they are, and these are all x0, so that's an x0 as well. Then we have this, which I'm summing this way. So this is 0, and that's 0 initially. And then 1 and 1, you can see those terms are 2 and 2, 3 and 3. So we're done with these two. Now we're here, and we're summing over C initially. So 0, 0, 1, 1. Sorry, where are we? C is here. So these here are 0, then they're 1, then they're 2, and they're 3. And D is left as is. And then we're summing over C, where are we? Here. And so we see the 0s, 1s, 2s, and 3s. And now we have to sum over D. So we rewrite some of these here. And we sum over D. And we get all of these terms. And then we have to look up the connection coefficients to see which ones survive. And that takes us to my calculations here. So it's very tedious. But I went through these, and we should go through them at least once, if not out of respect for Karl Schwarzschild, who had to do these calculations in the trenches. So these are the terms that survive, given the connection coefficients that we worked out before, and this whole thing has to be equal to 0, because we're in empty space. And then I looked up the connection coefficients, and here they are, and I put them in here. We're taking the derivative with respect to x1, which is r. And then we have these two terms are multiplied by each other. Here they are. These two terms, and so on. And then I further work these out. I have upper G11s, and I'm going to replace that with G11 lower. And so they're just the inverse, and G naught naught upper. Here we can see those. Replace that with 1 over G naught naught lower. Here I just sort of ran out of space, but it's the same term that I have here. And then I do the same thing for G22, except these can be evaluated explicitly because we know what they are. And so we are down here, and finally this is the equation that we get. So this is what the R naught naught equals 0 looks like. And so we see it's a differential equation in the unknown g naught naught, second derivative of that with respect to the coordinate r. So we could write this out with respect to r. This is also with respect to r of g naught naught. But we also have the unknown g11 here. We have derivative of g11 with respect to r and derivative of g naught naught with respect to r. And then we have g11 here and derivative of g naught naught with respect to r. So we're going to look at r11 and then I think r22, and then we'll combine them together to solve the system of differential equations to finally get our metric, or what's called the Schwarzschild metric.